It is a great honor also for me to be the moderator of this discussion and to make the introduction. Professor Ricardo Hausmann is the founder and director of Harvard University's Growth Lab and professor of the practice of international political economy at Harvard's Kennedy School. Before joining Harvard, he was the first chief economist of the Inter-American Development Bank. He's published very widely on a vast number of development-related subjects. But if I may, I would like to cite a remarkable 5-page paper that appeared in the July 2007 issue of Science, which paper figured centrally in probably the best seminar I've ever been able to teach at Colgate University. That paper, entitled "The Product Space Conditions the Development of Nations." He co-authored it with 3 other economists, and that paper changed the way economists think about the mechanism of learning and development. In that paper, Professor Hausmann and the other authors explained that the ease with which technological spillovers occur lies at the heart of differential rates of development. In their work, this insight is visualized as a product forest, where spillovers occur most rapidly and easily in a dense part of the forest, and less so on the fringe of the forest. This visualization from this paper of 2007 has been taken up by numerous other scholars. It is particularly valuable in the Caribbean, where it provides insight into the region's sluggish modernization process. Specifically, Hausmann has written a valuable paper on Trinidad and Tobago's experience as a petroleum producer, a paper, of course, that provides insight into what awaits Guyana. The title of Professor Hausmann's presentation today, "True Development and Natural Resources, What is the Connection?" promises to build on that framework developed originally in 2007. And so it is my privilege and my honor to turn the microphone over to Professor Ricardo Hausmann.
Thank you very much, Professor Mandel, for that very, very generous introduction. Thank you to the university and to the UN for the invitation. Thanks, Jose Lobo, for the connection. It's really an honor and a pleasure to be with you today. As you know, I'm Venezuelan, so I've been right next door with you in a country that has probably the largest oil reserves in the world and has been able to transform it into a total mess. As they say, only barbers learn in other people's heads. But so I'm going to try to share a little bit of the things that I have learned about development in general and development in oil resources. As the head of the Growth Lab, I've had the opportunity to work on Saudi Arabia, on the Emirates, on Oman, on Kazakhstan, on Colombia, on Ecuador. So the issues that Guyana confronts today are issues that other societies have confronted in the past, with mixed success. But I cannot think of Guyana without, maybe a healthy or not so healthy degree of envy. I'm really excited by the challenges and opportunities that lay before you. So with that introduction, let me start with the presentation I've prepared for you. You have come about, a fantastic level of newfound wealth, and the question is, how can you transform that newfound wealth into true development? And that's what I'm going to try to address. The issue of, what's the secret of the wealth and poverty of nations is something that is a question that got economics started. But when Adam Smith wrote The Wealth of Nations in 1776, the poorest country in the world, the richest country in the world was the Netherlands. And it was about 4 times richer than the poorest countries in the world, which are many countries that were at subsistence. So the distance between, say, the Netherlands and the poorest countries in the world was a factor of 4. If I download the data from the World Development Indicators, it suggests that the countries with the lowest GDP per capita in the world today is Malawi. If I multiply by 4 the income per capita of Malawi, I barely get to Haiti. And if I multiply by 4 the income per capita of Haiti, I get to Morocco. And if I multiply by 4 the income per capita of Morocco, I get to Poland. And if I multiply by 4 the income per capita of Poland, I get to Singapore. So a problem that was a problem of 4 to 1 has become sort of a problem of 256 to 1, which is sort of like scientific proof that the problem does not go away by just reading Adam Smith, right? It has become much, much bigger. And the reason why it became much, much bigger is that the world underwent a fantastic transformation. This is GDP per capita of the world since the year 0. And you see it was sort of like flat forever until something that happened about 2 centuries ago. And that thing that happened about 2 centuries ago happened differentially in different parts of the world. So that while in 1776, which is before this graph starts, the differences were sort of like, say a factor of 4, these differences now have exploded. And it is these differences that allows you today to take this picture and at the same time take this picture. Now you might say, obviously, these 2 pictures suggest radically different ways of producing things, radically different technologies with different forms of production and so on. But the interesting thing is that if I asked you as a homework assignment, if you want, to take a picture of a typing machine, you'd really have trouble finding a typing machine to take a picture of. And that's because typically good technology displaces bad technology or more backward technology. So the question that we want to ask ourselves is, why is this picture still possible to be taken in the world when this is possible? Why did this not go the way of the typing machine? For that, we need to have a better understanding of what technology is. And why would good technology not just displace, more backward technology? Now, technology is a word that economists love, but they don't like to define very much. The typical definition of technology is sort of like a none of the above category. It's not physical capital, it's not human capital, it's not land, so it's something else that makes things more productive. But economists don't define it, and I'm going to define it. I'm going to argue that technology is really productive knowledge. It's knowledge we use to transform the world. It's different from science, if you want, which is what they call propositional knowledge about the nature of the world. Technology is really how we transform the world from what it is to how we want it to be. Say, how we transform a meadow into an omelet. And well, we have to do a lot of stuff, with chickens and eggs and cows and milk and so on, and a lot of transformations of the world in order to make the world into the world we want. Now that productive knowledge exists in the world in what I would like to call 3 ontologies, if you want, 3 forms of reality. The first one, it exists in the forms of tools and materials. So as tools and materials, this knowledge is embodied in the tools and materials. So you don't need to know how to make a drone in order to use a drone. The knowledge necessary to make the drone, the things that makes the drone fly and so on, are all embedded in the drone. So you don't need to know it. Somebody needs to know it. You just need access to the tool. Technology is also codes, recipes, formulas, algorithms, how to do manuals. And in that form, so technology is knowledge that has been codified. It has been transformed into a symbolic space, into a conceptual space. So in this picture, you have ink over paper, but the knowledge is not in the ink and it's not in the paper. And actually, this is not ink over paper. This is a picture of ink over paper. And the fact that you took the picture doesn't change the meaning, right? So it's living in some symbolic space. Now, tools and materials can be shipped around, so they're easily moved. So if technology was only tools, then we would create an NGO and send those tools to Malawi or Haiti, and then we would have solved the problem. Codes can be easily shared, right? We can put the codes on the web, we can email them, we can publish them. So in principle, codes shouldn't have much trouble moving around. Now, there is a third form of knowledge, and we will infer what that form of knowledge is by asking ourselves the question, what do you do when your tooth hurts? One possible answer is that you download an article from the web and ask your significant other to follow the instructions. But we don't do that. We go to a dentist, and the dentist is somebody who uses tools. The dentist follows protocols, follows the codes, but the dentist mixes the tools and the protocols with something that you and I probably don't have, which is the ability to look into the mouth and see things that we don't see, and the ability to use the tools in ways that we don't know how to use the tools. So that third form of knowledge is something that exists in brains and only in brains, and we call it tacit knowledge or know-how. So the three instantiations of productive knowledge is as tools and materials, as codes and recipes, and as know-how or tacit knowledge in brains. Okay, now, know-how is the ability to perform a task. For example, you might say that Rafa Nadal knows how to play tennis. But the ability of Rafa Nadal to play tennis is something that is not really in his mind. It's more like in his brain. His brain responds super quickly to a ball that's coming to him at 140 miles an hour. He doesn't have much time to ponder and reflect upon. His brain does that more or less automatically in a very non-conceptual way, what Daniel Kahneman would have called System 1. And that means that know-how does not move from brain to brain by talking. So I can guarantee you that if you have a long conversation with Rafa Nadal, your tennis game will not improve. So that's not how know-how moves. Know-how moves from brain to brain through a long period of imitation, repetition, feedback, imitation, repetition, feedback, and something that Malcolm Gladwell says takes 10,000 hours of practice. So know-how is a very slow-moving form of productive knowledge. Know-how does not involve comprehension, and that makes it harder for it to move. So, know-how is the kind of thing we use when we walk. So we know how to walk, but we don't actually, know what it is that we're doing when we walk. We don't know what muscles we move. We don't know how we keep our balance. We don't know how we regulate our breathing and our heartbeat to keep the body oxygenated as we walk. All of these things are in our brain and not in our mind. And the problem with modern technology is that it requires not individual know-how, it requires team know-how. It requires different people knowing about different things and collaborating. So it would not be appropriate to say that this gentleman here knows how to implement the technology in the background. To implement the technology in this background, you need all these other people who know about different things, and they have to come together in the implementation of that technology. So I'm going to argue that the true challenge of development is know-how. And it's this team know-how, what I'm going to call collective know-how. Now, I'm going to try to measure this know-how in the world. And I'm going to try to ask myself, how does it grow? And that's going to be the core of my presentation. So, but to measure know-how, I have to ask myself, how would I go about measuring it? Okay. So I'm going to compare two individuals. Here is an Inuit from northern Canada, and here's the Inuit engaged in food production. And here's the Inuit engaged in housing construction. And here's the Inuit engaged in transportation. And I'm going to ask myself, who has more know-how, the Inuit or modern man? And here you have modern man using headphones, using a shirt, using a watch, using a computer, using a screen, probably using software. He doesn't know how to make any of that. If you bring modern man here, there must be a mathematical theorem that proves that he will die, right? We don't know if he will freeze to death or if we will starve to death, but he'll not survive in this environment. So there's no practical sense in which you can say that modern man, this guy in particular, has more know-how than this guy. But it makes sense to say that the society to which this guy belongs has more know-how than the society to which this guy belongs. And we know that the society to which this guy belongs has more know-how because they know how to make glasses, they know how to make headphones, they know how to make shirts, they know how to make watches, they know how to make computers, and so on. He doesn't. Somebody does. Somebody out there does. He doesn't. While the society to which these guys belong, everybody pretty much knows how to hunt, everybody knows how to fish, everybody knows how to make igloos, everybody knows how to make dog sleds. So in some sense, everybody has in their heads the full copy of their technology. That's why as individuals, they are capable of surviving in places that, other humans cannot. So they have a lot of very valuable know-how, right? But they have less of it because they can do fewer things. And the reason why they can do fewer things is not because they know individually less. It's because they all know essentially the same. So the punchline of this story is that modern society knows more, not because individuals know more, but because individuals know different. That the growth of knowledge has to do more with the division of knowledge in different heads. Okay, that you store different bits of knowledge in different heads. So the whole knows more because individuals know different. Now that we have put different bits of knowledge in different heads, and a little bit these 10,000 hours that Malcolm Gladwell talks about indicates that we don't have that much space to put in each individual's head. So that's one of the reasons why your dentist tends not to be your lawyer, right? That we specialize people in different areas of knowledge. So let's assume that there's some kind of limit to how much knowledge, especially know-how, not conceptual knowledge, but know-how, these automated things in the brain that take so much time to imprint, to rewire the brain to know. Let's assume that the amount that fits in a brain is not, say, 1 kilobyte or 1 megabyte or 1 gigabyte or 1 terabyte. I don't know how much fits in a brain. I'm going to call it 1 person byte. Now, we can ask the question, how many person bytes does it take to make a product? And the answer, obviously, it depends. There must be some products that can be done by 1 person, so fits in a person byte. But products that require more than 1 person byte have to be done by more than 1 person. And we aggregate these person bytes by having people collaborate in firms. So in a firm, somebody knows about accounting, about finance, others about human resource management, or about taxes, or about production, or about procurement. So different people know about different things, and they come together in firms. And because that's not enough, they buy a lot of inputs from other firms that have different teams that know how to do these inputs that they're going to use. So the amount of knowledge that a society mobilizes in production is expressed in the networks of people that are going to be collaborating in the production process. So if you ask yourself, how many person bytes does something require? It's useful to ask yourself, who needs to collaborate to make those products? And here is a subsistence farming family in Ecuador. They know how to make all of these things that they eat. So you could say that, the knowledge necessary to make these products resides in this family. And they can be quite autonomous from the rest of the world. They can interact very mildly with the rest of the world. You can imagine that these businesses that I have in this chart are really all family businesses. So the knowledge necessary to run these firms may reside in those families also, but they are not independent subsistence people. They need to interact in a market. So in this setting, nobody can make a hamburger alone, right? Because to make a hamburger, you need both the baker and the butcher, but so you need to somehow integrate, but each production unit can be more or less run by a family. No family can make these products. And you could say that no country can make this product. This is the Boeing 787, the Dreamliner. And here it's supposedly done by Boeing, but Boeing is this pinkish, purplish color here. So Boeing actually makes very few of the parts that go into the aircraft. It's made by all of these companies across all of these geographies. It's very different to know how to make a turbine than to make a landing gear and so on. And all of this knowledge has to be done in all of these firms that have to come together. So it's a huge network of people that have to interact, not because they're going to make many aircraft. They have to interact just to make the first aircraft, okay? So the amount of knowledge that is being aggregated in society depends on these networks of people that with distinct knowledge, that have to come together to do things. So I've tried to capture this idea in what I call the Scrabble theory of development. So I'm going to assume that these person bytes of knowledge, or these units of productive capability, if you want to call it, are like letters, and products are like words. They're made by putting letters together, by putting these person bytes together. So if you only have one letter, there aren't too many words you can put together. But if I give you these 3 letters, now you can make 4 words, and we can make 3-letter words. If I just give you 1 extra letter, now you can make 9 words, and you can make 4-letter words. If I give you these 10 letters, according to the Scrabble website, you can make 595 words, and words that are up to 10 letters long. So the moral of the story is that the more letters you have, the more words you can put together. So the more diversified your production will be. But also the more letters you have, the longer the words you can put together. So maybe you'll be able to do things that are more complex, harder to do, things that require more know-how. So when we look back at this picture, I want to ask myself the question, who has more know-how? And the answer sounds like the answer to the Eskimo question, to the Inuit question, right? I mean, the guy on the left, he knows how to take care of his own bulls. He knows how to make his own tools. He knows how to make his own fertilizer with dung. He probably uses his own seed. He makes a lot of decisions. The guy on the right, he uses a harvester. He doesn't have a clue how to make a harvester. The harvester probably is not that much less complex than the Boeing 787. So it requires a huge network of people to make that harvester. That harvester uses gasoline. Don't get me started into how difficult it is to find oil, to extract oil, to refine oil, to transform oil, etc. He probably uses genetically modified seeds. He doesn't know what the term means. He uses pesticides, agrochemicals, fertilizers, doesn't know how to make any of that. So there's no practical sense in which you can say that the guy on the right has more know-how than the guy on the left. But it makes sense to say that the guy on the right is part of a network that's mobilizing massive amounts of knowledge, while the guy on the left is pretty much working on his own. So you would say that the guy on the right is a letter in a very long word. And the guy on the left is probably a very short letter, a very short word, okay? So that's what I think underpins these differences in productivity. It's in the network of knowledge in human brains that has to be mobilized to move things. So I'm going to use this intuition to measure the amount of knowledge that countries have, the amount of know-how that they have. And the first one is to say that the more person bytes you have, the more know-how you have, the more products you'll be able to put together. So you'll be more diversified. And the diversification of a place is something I can go out and measure. Second idea, so for example, here is Nigeria's export basket. It's almost all oil and very few other things. And Nigeria is a country of 200 million people. On the right, you have Austria, which is a country of 9 million people. And you can see just the variety of the things that they know how to do. They know how to do more, not because they have more people. It's just because they have more diversification of the knowledge between people, different people knowing how to do different things. So a second intuition is that products that require more letters are going to be more difficult to do. They're going to be feasible only in countries that have more letters, right? So products that have more letters are going to be made in fewer countries. They're going to be less ubiquitous. And I can go to the data and ask, how many different countries or how many different places are able to make this product? And that's something I can go out and count. So for example, if you ask yourself who exports raw wood, well, many countries export raw wood. If you ask the question, who exports microscopes? Well, few countries export microscopes, okay? And that sort of captures the intuition that probably raw wood is something easier to do than microscopes, right? So these are things I can count. So countries that have more letters should be able to make longer words, that is, words that are harder to make, that is less ubiquitous products. And that's exactly what we find in the world. This is a graph that on the x-axis, you have how many products a country makes, and on the y-axis is on average, how many other countries make the things you make. And the rich countries are all at the bottom right. They make many, many things and things that few other countries make. And the poor countries are all at the top left. They make few things and things that everybody knows how to make, or that many people know how to make. So this is what you would observe if the underlying difference between places was differences in the number of letters that they have and the variety of letters that they have. And by the way, this can be done at the world level. If we do subnationally, these are municipalities in Chile. So here you have Santiago, Las Condes, and Providencia, which are 3 municipalities of the Santiago metropolitan area. And at the top left here is, the Atacama Desert and the place where the penguins live in the south, right? So they make few things and things that everybody knows how to make. And this is true of Mexican states. Here you have Federal District and Nuevo León, which is the city of Monterrey. And here you have the poor southeast of Mexico. These are cities in Turkey, Istanbul. Note that there are 400 kinds of industries in Istanbul that are not in Izmir, the second largest city, and 100 more industries that are in Izmir and not in Ankara, okay? And here's the poor southeastern Kurdish region near Syria and Iraq. So these are Colombians call them departments in Colombia. So here's Bogota and so on. These are districts in Sri Lanka. Same, here's the capital. And so you have these structures repeat themselves. They kind of tell you some places have a lot of letters. They can do many things and things that are done in few other places, and other places have few letters and they make few things that are done everywhere. So this allows us a trick to measure how many letters a country has. And that's a paper I published with Cesar Hidalgo in 2009. And it allowed us simultaneously sort of develop a metric of, what letters are long and what products are more complex and what products are less complex. So what words are long and what words are short. So here at the bottom, you have short words, and among them you have crude oil, so less complex products. And at the top, you have the more complex products, okay? So we can measure the complexity of products, and we can measure the complexity of countries, okay? Here, this is a heat map. So red means that you have a lot of letters. And, it's interesting to see that you get exactly what you would expect, that the US and Western Europe have a lot of letters together with Japan, that China has less letters than Japan, but more than India, that in sub-Saharan Africa, South Africa has a lot of letters, that Venezuela has very few letters compared to Colombia, and so on. Now, interestingly, if this is our metric of how many letters a country has, by just looking at how many things that they do and how many other places do the things that they do, okay? So that's our index of economic complexity. And let's ask ourselves the question, does it matter for how rich you are? And here I have all the countries in the world for which we use data. It's about 120 some countries. I didn't have the right data for Guyana, unfortunately. But I put in blue countries where natural resources are not that important. And for them, there's a very tight relationship between how many letters you have and how rich you are. And in red, you have countries that have more natural resources. And notice that for those countries, the relationship is a little bit messier, but also that the red countries tend to be above the blue countries, meaning that for the amount of letters that they have, they tend to be richer. And we know why they're richer. They're richer because they have natural resource wealth. The countries at the top are Norway, Qatar, Saudi, Trinidad and Tobago, Oman, Venezuela, Libya, etc. It's a little bit messy because not all of them have the same amount of natural resource wealth. But if I control for that, I get this relationship, which is a quite tight relationship between how many letters you have and how rich you are. The R squared is 0.73. So you explain 73% of the variance with just, counting how many letters you have and how much natural resource income you're getting. But you might say, well, but the theory is not perfect because there's a lot of errors. That is, not all countries are on the regression line. What are these errors? Are these errors mistakes of the theory? I would like to say, no, these errors are mistakes of the world, in the sense that these errors are informative. For example, down here, you have India. The theory would say India should be here. India should be richer given the amount of letters that it has. And it says that Greece should not be up here. Greece should be down here. Greece could not be so rich given how little they know. Well, guess what? This was done with 2008 data. And since then, India has grown a lot and Greece has gone to hell. So the idea is that these error terms actually contain information about where countries are going. They're in some sense more fundamental than countries' current income. They say something about countries' sustainable income in the longer term, okay? And Greece maybe got there by borrowing a lot of money that they were unable to sustain. And India has what it takes to be richer, and it's just in the process of expressing it. Okay, so I hope to have convinced you that it's important to have that the secret of development has something to do with, you know, getting more know-how, and more know-how means people knowing about different things, not people on average knowing more, people in different people knowing about different things. So it's this diversification of know-how, the division of know-how, and we can observe it by looking at how many words they can put together, how diversified they are, and how complex are the things that they can do, how difficult it is, the things that they can do, as captured by the few countries that are able to do them. Now, now we want tricks to accumulate more letters. How do we accumulate letters? And to accumulate letters, we need to solve this chicken and egg problem. And the chicken and egg problem is that to diversify, you have to start doing things you were not doing before. But you cannot, but to do things, you have to know how to do them, but you typically don't know how to do the things you don't do. So how do you start doing things that you don't know how to do? If to do them, you have to know how to do them, but you don't know how to do the things you don't do. How do you start making watches? If to make watches, you need watchmakers, but nobody can become a watchmaker in a place that doesn't make watches. So how are these processes solved? How can we accelerate this solution of the chicken and egg problem? And this problem is somewhat related to the following classification problem. The classification problem is you have here three animals, the bear, the lion, and the zebra. And the question is, which two animals are very related to each other, and which third animal is out of the group, is a very different kind of animal? And, you know, different people will classify them differently. Some people would say the lion and the zebra are from Africa. Other people would say that the zebra eats grass, and the lion and the bear like to eat things that eat grass, or so they live in different, what scientists call trophic levels. But if you use the Scrabble metaphor, you'll realize that a zebra is just a bear with an extra Z. So the distance between bear and zebra in Scrabble space is just one letter. Well, the distance between bear and lion is very large, because with bear, you have four letters that are useless to make a lion, and lion needs four letters that you don't have. So in Scrabble space, the bear and lion are far away, bear and zebra are nearby, okay? So that is the intuition that lies behind the product space that Professor Mandel was mentioning, that I'm going to start to introduce. So what I want to introduce is the idea that we can represent technology as if it was a forest, where every product is like a tree, and that the distance between trees in the forest is going to be related with how similar are the letters that they require. So in this forest, bear and zebra are going to be relatively close to each other, while the lion is going to be farther away in the forest, okay? So when we did that, this is what we came up with, okay? This is a representation of this product space. In this representation, every product is a circle, and it is connected to other products if they share a lot of the capabilities that the product requires, okay? So I'll describe very quickly what this is. By the way, this is the data organizing itself. We didn't put it there, sort of like the data put itself there. But this green cluster here are garments. It suggests that, you know, if you have what it takes to make one kind of garment, it's sort of like easy to make other forms of garment, because it kind of use the same letters. These are garments. These down here are textiles. They're farther away. You might say, well, but you need textiles to make garments, but you don't actually need to know how to make textiles to know how to make garments. You can just bring the textiles in, because the textiles can become embodied knowledge in materials. You don't need to know how to do it to make the garment. You just need access to the embodied knowledge. You don't need to know how to do it yourself. So these are garments. This is agro-processed food here in brown. Here is construction materials. Here in blue, dark blue is machinery. The big one here is cars. By the way, the size of the circle is proportional to world trade in that product. This here is trucks. These here are chemicals. These here are electronics. Unfortunately, there is a periphery of products that are very poorly connected. So think of it as there are parts of the forest that are very densely packed with trees. So it's very easy to move from one tree to another, while the periphery of the forest is very sparse. And so it's not very well connected. At the end of the world here, very poorly connected, is oil. Okay? So oil is very poorly connected in the product space. So if you have what it takes to make one kind of machine, say a refrigerator, you can probably, with the same workers and the same machines and the same many things, you could be able to make, say, air conditioners, refrigerators, white goods, etc. So, but if you know how to make oil, it means that you know how to make holes on the ground. If anybody else needs a hole on the ground, I'm sure they'll give you a call, right? But it doesn't have the kind of spillovers that some of these do have, okay? So now that we know what technology is, we can ask ourselves, what is a country? And I'm going to say that a country is a collection of teams that can implement a technology, a collection of teams that can make products, okay? So a team making a product, I'm going to use the metaphor that it's like a monkey living on a tree. So it's not the tree, it's the occupation of the tree by a monkey. So I can characterize a country by where it has its monkeys, okay? What part of the product space has its monkeys? I saw Aura raised her hand. Maybe I can take that question, Aura. Well, I guess I'll continue. Anyway, see, although it, okay, yeah. So the question was, correlation is not causation, and I agree with that. I'll elaborate a little bit more. Correlation is not causation, but interestingly, the fact that your complexity today is useful to predict your income tomorrow suggests, what is the direction of causality. The fact that tomorrow is explained or is accounted for by something that happened today, and that so like today's complexity predicts tomorrow's income, but today's income does not predict tomorrow's complexity, is somewhat evidence in the direction I'm suggesting. So this is a product space. That means that products can be characterized at least in two dimensions. The first dimension is how long is the word? And I mentioned that we can measure the complexity of products, or how long is the word? So machinery is more complex than garments. But this one here is sort of like, how dense is the forest in that part? How dense is the forest around where the machines are made, and how dense is the forest around where the garments are made? And you see that the forest is very dense in both in garments and in machinery, okay? But garments are simpler products than machines, okay? So making garments uses less know-how than making machines, okay? You need less diverse skills to make garments than to make machines. So that already shows that different parts of the product space are going to be different. So now I'm going to characterize a country, and a country, as I said, is a collection of monkeys, and I can ask myself, where are the monkeys? And I'll start with my own country, Venezuela. So here's the product space all grayed up, and I'm only going to put in color the places where Venezuela had monkeys in the year 2017. And these here are, are oil and oil products, oil and natural gas, and here are very basic oil transformations, very much in the periphery. Very few monkeys here, okay, in the country. If I compare Venezuela to Mexico, Mexico has many more monkeys. So this is Venezuela, Mexico. Mexico is a country of 120 million people. Venezuela used to be a country of a bit over 30 million people. Now it has probably 25. And I'm going to compare now the two of them to Austria, and that's Austria. And you see, Austria has their monkeys everywhere, okay? Especially in this central cluster of more complex products and so on. Then I can ask myself the question, do monkeys move? And can I observe monkeys moving? And to illustrate that, I'm going to compare Ghana to Thailand. And they both started in 1962 with very similar levels of income, but Ghana expanded its education faster than Thailand. So you would expect that Ghana outdid Thailand, but education is not the same thing as know-how, and that's not what ended up happening. Ghana started making cocoa and wood and some minerals, while Thailand started making a bunch of agricultural products, a little bit more diverse, but all sort of like same colors, same kind of things. And here's where they were in the product space in 1965. Again, the product space is sort of like dimmed out, and only these places that are highlighted are where they had monkeys. So now I'm going to show you the movie of what happened between 65 and 2010. So this is 65, 70, 75, 80, 85, 90, 95, 2000, 2005, 2010. Let me go back to show you what happened. So 65, 70, not much change. 70, they start to populate the garments cluster here. 75, they start moving to this agro industry cluster here. And then they get two monkeys here in the electronics cluster. Suddenly, boom, they take over all the electronics cluster. And they start moving some monkeys here to the machinery cluster. And lo and behold, they start moving into more machines, and they eventually populate a lot of the machinery cluster and start abandoning the garment cluster. In the meantime, very little stuff is happening in Ghana. Okay, so this was Ghana in 1962, and this is Ghana in 2010. So there's some transformation. You get more products. Some of them you go from cocoa beans to cocoa paste to cocoa powder, etc. A little bit more minerals and stuff. This is what happened to their exports per capita in constant dollars. They essentially went over. They collapsed when cocoa collapsed in the 1970s and 80s. But they're still sort of like at below the levels of exports per capita that they were at in the 1960s. This was Thailand before. This is Thailand now. So you see there's a dramatic transformation, not because the things that they were doing before disappeared. These things are still there, but just because they added a lot of stuff that was not there. So when you look at their exports per capita, they went from below Ghana's. Ghana was at $200. They were at kind of $50, and they are now at $3,000 per capita. So as a consequence, Ghana and Thailand diverged in incomes per capita. Okay, so it was really the process of accumulation of know-how, its expression in more industries and more complex industries that underpin their story. And we can look at different countries and ask how many monkeys jumped and how much did those monkeys jumping add to national income. So we essentially explain growth, or we try to account for growth by measuring two dimensions. The first one is, are you above or below the regression line here? Are you more like India, that has more than enough letters to be richer than it is, or are you more like Greece? And the second one is, how well positioned is your country in the product space? So here's how many letters you have. This is how close are your monkeys from empty trees. And unfortunately, my home country, Venezuela, is here. It has very few letters, and the monkeys that it has are very peripheral. They're very far from other trees. Austria is over here. Austria is over here. They don't have any empty trees left. So they're not well positioned in the product space in the sense that they don't have close empty trees to jump to. And interestingly, India is at the top here. They have an intermediate number of letters, but they have many empty trees to jump to. And by the way, Greece is in a similar position. They have an intermediate number of letters, and they have many empty trees nearby. So Greece and India in the previous chart were so like opposite, but in here they kind of like resemble each other. So we use this to put a sort of like a 2x2 matrix of where countries lie. In some countries, you know, they have more than enough letters to be richer than they are, and it's easy for them to get more letters because they're well positioned in the product space. They can jump from bear to zebra and catch, you know, one letter at a time. These countries have more than enough letters to be richer than they are, but it's hard for them to get more letters. So maybe they should just try to get more out of the letters that they have. These countries need more letters, but it's relatively easy for them to get them, you know, jumping from bear to zebra, say one letter at a time. And these countries need more letters, but it's hard for them to get them because their monkeys are far away from other trees. So they need somehow to jump over distances that monkeys have trouble covering. Since we did all of this empirically, we can figure out where our countries, and India and China are over here, and that's the reason why they grow so much. Greece is over here, right? They have more, they don't have enough letters to be as rich as they are, but it's sort of like easier for them to get them. And Venezuela is over here. So that's my first take. Every country has to play with the letters that they have. Let me ask the question, should you focus on adding value to your raw materials? You know, should you build a refinery? Should you build a petrochemical industry? Should you, add value to your raw materials? This is a little bit of the question of, what should Finland do? Finland is a country that has a lot of trees. So you might say, well, since you have so many trees, why don't you make wood? But then you say, well, but don't stop at wood. Why don't you add value to your raw materials? Why don't you make furniture? Or maybe go in a different direction. Why don't you make paper? And by the way, Finland ended up doing all of these things, but that's not what ended up making Finland rich. Finland, had a lot of trees, and because they had a lot of trees, they had to cut those trees. So they developed tools and so on to cut those trees. But then they decided, well, it's easier to develop to cut trees and sow trees if you have machines, and so machines that cut wood. But then they said, well, why machines that cut wood? Why don't we automate the machines that cut wood so that we can do them, better and less labor intensive or something? Well, they say, if I can make machines that cut wood, I can make machines that cut other things. Not everything is made out of wood, so I can make automated machines that cut other things, or machines. From there, you might do machines that don't cut anything at all, because now you know machines that cut, you can make machines that don't cut, that do other things. And that way they ended up in Nokia. And they became the biggest producers of cell phones. But interestingly enough, they couldn't make the transition between cell phones and smartphones. And so, but the interesting thing of the story is that this is a path of development where you add value to your raw materials. This is a path of development where you add capabilities to your capabilities. That you develop a capability because you had a need for it, but once you develop that capability, it opens up the possibility that if you were to add another capability, you can move in a completely different direction, in a completely different market. So this is a very important lesson, in my opinion. In fact, adding value to your raw materials only makes sense if it's very costly to move your raw material vis-a-vis the cost of moving the final product. So you might say, well, it's very costly to move a tree. It's much easier to move wood. So it makes sense to cut the wood near the tree so that you save on the transportation cost of the tree. But it's not true that it's cheaper to transport gasoline than it is to transport oil. Actually, it's cheaper to transport oil because oil is one thing. Once you put oil in a refinery, it's 15 different things that you have to keep in 15 different vessels. So it's actually cheaper to process the gasoline, process the oil close to the point of consumption rather than close to the point of production. This is going to be important for Guyana because, if you start building a refinery now, you'll probably finish it by the time that the world will have moved on from oil, and we will have all those stranded assets. So, second idea I want to say on how to expand know-how is by noticing that putting know-how into brains is difficult. Malcolm Gladwell, the 10,000 hours, but it's much easier to move brains. And this is something that the world has figured out. And we see it in the movement of know-how between firms. So the founders of Ford, General Motors, and Chrysler all worked for Oldsmobile. So they worked in Oldsmobile, they were trained in Oldsmobile, they realized how a car company runs, and then they moved and set up shop on their own. So the same thing happened in Silicon Valley. Shockley took 8 guys from AT&T Bell Labs in New Jersey, took them to California. The 8 guys separated from him and founded Fairchild Semiconductor. And then those people founded all these other companies, right? So they came from Bell Labs and they moved to California, and then they created Intel, they created all these other companies. And so the movement of know-how moved between firms by having the brains move, okay? A similar story can be said about Bangladesh, where Bangladesh was an exporter of jute in the 1970s. In comes Daewoo and says to Bangladesh, I want to sell you stuff. And Bangladesh says, I don't have dollars. If you want to sell me something, you have to buy something from me. And Daewoo said, well, there's nothing I can buy from you that you make, so maybe I'm going to establish a shirt manufacturing plant in Bangladesh, which was called Desh. And they took 126 Bangladeshi workers to a 6-month training program in Korea. And then they sent them back. By 1988, 56 of these 126 Bangladeshis left the company to start their own company. And this is what happened afterwards. There's a fantastic boom. Today, garments are 95% of Bangladesh's exports. And the 56 companies that were started by the people that were trained in Korea, etc., and worked for Desh are the core of the manufacturing exporters of Bangladesh. So the knowledge of how to make apparel, it was infected from that process. So in sum, economic development results from the adoption of technology. Technology is tools, codes, and know-how. Of these, know-how is the hardest one to move. It exists only in brains. It doesn't exist in any other form. So the process of accumulating that know-how has outsized effects and growth. Societies accumulate know-how by putting different bits of know-how in different heads. Expanding your know-how faces these chicken and egg problems, which means that growth tends to become parsimonious, that you tend to solve these chicken and egg problems preferably once at a time. That means monkeys move preferably to nearby trees. It's easier for the monkey to move to nearby trees. Countries face very different options in terms of how to redeploy their knowledge. They're not equally positioned in the product space. You can accelerate the process of know-how by bringing it from abroad through labor mobility. So moving brains is faster than moving know-how into brains. Let me make some final comments on Guyana. First, how are you going to manage your oil wealth? In Venezuela, we used to say that oil is a non-renewable resource, but actually financially, oil can become a permanent resource. If you take the asset out of the ground and you put it into financial assets, it now becomes a permanent source of wealth. So you have the opportunity, because your oil income is going to go up so quickly that it'll be hard to spend wisely. you have the opportunity to go Norwegian, to accumulate those assets and to transform it into a permanent source of wealth. I'm betting that by 2050, you're going to be making very little money out of oil. At least I would have my money there, but I would want you to be permanently rich. And 2050 means your children, your grandchildren. So I would go Norwegian. That's a first comment. Second comment is think Dubai. Don't think Trinidad and Tobago. Think Dubai in the sense that Trinidad went into petrochemicals and they didn't do too well in that. A little bit adding value to your raw materials. What Dubai did is that they had oil. With that oil, they built a lot of infrastructure and amenities and so on. And so with that infrastructure and amenities, they carved out a role in logistics, in air travel, in tourism. And then they started attracting the regional headquarters of multinational corporations and international financial center, etc. All of the things that happen in Dubai have nothing to do with oil. They happen to do with capabilities that were accumulated thanks to oil, but they had nothing to do directly with oil. So it's a little bit like the Nokia example I gave you. It's because you have oil, you will be able to accumulate some capabilities. Ask yourself, what could you do by adding capabilities to those capabilities? Don't think too much about what's happening to the oil itself. Think about what's happening to your capabilities. Think know-how. Think how you're going to bring know-how into the country. Don't think too much about money because you'll have more money than you can spend. It's know-how that is going to be slowing you down. And it's know-how moves a lot when people do. So Dubai has 1 million citizens, 9 million foreigners. Saudi Arabia has 10 million citizens, 20 million foreigners. Given how much money you're going to have, a lot of the know-how is going to come by people pouring into the country. So you're going to have to think hard about your immigration policy. But you also were, up to very recently, a country of very strong out-migration. And, I know in the Caribbean, all the doctors, the nurses, all the intellectuals were all Guyanese. So you have an interesting, very capable diaspora. And that diaspora has been accumulating experience in other places, knowing about other things. We've been working with many countries on how to make use of their diaspora, how to use their diaspora as a diversification asset. And if you want, I just did a project last year on a strategy for involving the Colombian diaspora and Colombian development. And previously we had work on Sri Lanka, on Albania, on Ethiopia in terms of diaspora policies. So immigration and diaspora policies, I think, are going to be critical to facilitate access to more knowledge. Let me stop there. I think I went way over time, but I got excited sharing these ideas with you. And so I'm looking forward to some discussion. Thank you.
Well, thank you. That was a fantastic lecture.